Now let's see if we can get our processes to play nicely together and look at the nice command and the renice command where we can start to control our process priority. Now you can see then that I'm running at the command line logged in as my standard user. And let's just go through and start up one of those sleep processes again. So let's just run it for the good old 1000 seconds and have that running in the background. Now if I use PS and -L within the long listing of PS, we get the priority and the nice value for a given application. The priority column, PRI, indicates then the CPU priority that that process has. And this is controlled by the nice value. We can see the default nice value of 0, which gives me a priority of 80. The nice value can run from -20 all the way through to +19. And the higher the number, so the more positive the number is, the nicer the application or the less CPU time it's going to take. We'll see then that we can adjust the priority all the way through from 60 through to 99, where 60 is a higher priority of 99 and 99 is the lowest priority. We're going to begin as the standard user and just seeing how we can control this ourselves, and then we'll see how the root user can set it for users and groups through a configuration file. We've seen then, without any intervention from me, the application sleep starts then with a nice value of 0 and a given priority of 80. Well, I can then go through and choose to start an application using the command nice. And we can set it, let's say, for its nicest value, so -n and +19. And we can then go through and run sleep and 1000. If we Control Z this and BG it, didn't start it in the background, but never mind. Now when we go through and look at our PS command, so PS -L, we can see now that we've got a CPU priority of 99 and a nice value of 19. Well, okay, we put the nice value in, but the CPU priority then was adjusted based on that nice value. So this is a really nice application or nice process, and it's running with a low priority. The higher the priority number, the lower the priority. Just think of it as a queuing system. 99 is at the back of the queue. Whereas if I go through and start something, let's say go and do this again, well, we go through and set it for a nice value of 1. Remember, I can't set negative values being an ordinary user, and we will start this in the background. And now when we go through and take a look at our PS -L, we can see now that that's adjusted to 81, the priority, with a nice value of 1. Now we can also use the renice command. So if I want to make an application more nice, I can do this as a standard user. So I could renice -n, and we can specify then 10 for the process, and we can go through and let's look at then the process ID of 14145, 14145. Now when we take a look at that, its old priority was 1, its new priority is 10. And when we go through and take a look at the output now, we can see that it's adjusted to a priority of 90 and a nice value of 10. However, what I can't do is go back and set it to 1. I can't set a lower nice value than it's currently running as. Only root can do that. Root can also, let's go through and take a look at Mr. Root. Root can also set negative values on startup. So if I go through and put in the root user's password, see what we mean by this. If I go through and take a look at nice -n and -20, remember we run from -20 all the way through to +19. And we can go through and run sleep for the good old 1000 seconds. Other values are available. And when we do a PS minus L within the shell here, we can then go through and see that that gets a priority of 60, so much further up in the queue than the default priority that we get with 80. And we can compare this with the other sleep processes. Remember, I can do a PS minus L and then minus P, and we can go through and use P grep on sleep. So we can see all of the sleep processes running, and we can see then the negative 20 and the positive 19 values. Now, another trick that Root has up his sleeve is to be able to configure the default nice value. And we can do this based on users, or we can do it based on groups. Let's just go through and take a look. I'm going to edit using Vi the /etc/security and then limits.conf. Now when we take a look at this, they give us some ideas of then how we can set users or groups. We can set soft or hard limits, and then for items. And we can see we've got an item there called priority. Let's move towards the bottom of the file. So we can go through and see that we've got some examples. These are all commented out. I'm just going to insert a new line, and I'll just do it for my Tux user at the moment. So if I go through Tux, we're not worried about hard or soft limits for this. It doesn't apply to the priority. And then we can go through and put in our priority. And then we can go through and say a priority of 10. If I was doing this for a group, then I would just put the @ symbol in front of the group. If I wanted it for all users, I'd just use the star. All I've got to do is go out and save this. Now if I exit back, I'm at the previous shell for Tux. And if I go through now and take a look, if I go through and run sleep, 250. So I'm not using any parameters here. We'll just make sure this runs in the background and PS minus L. We can see then at the moment when we've run that it's still picked up on the original. But if I go through and force a new login, and I can do this just using su minus and then Tux, put in my password. So then on a new login, now when I go through and run sleep 250, run it in the background, run my PS minus L. Oh, look and take a look. We can now see that we've started all of our new processes with a process priority of 90 and the nice value of 10. Remember, when we see settings within etc security limits.conf and we're setting the priority, it's really controlling the nice value. We can set it to a positive value. We could even set it to a negative value if we needed to give some users or groups more CPU time. And although we probably don't need it on our systems that we're running here, where we are CPU limited, this might be useful within your own environments. But in any case, we've seen how we can control through the nice, renice command, and then through the limit file, the priority of our processes. I think we need to jump back to our slides now so we can summarize this module a little.